Alright, so the next topic I want to introduce is the topic of lines. So, a line in the xy coordinate plane is typically given by the equation y is equal to mx plus b. So, m is probably the most important part about the line, and what it tells us is the slope. So the slope conceptually you can think about is your change in output divided by your change in input. And mathematically, what we do is we write this as, because y is our output, we do this little delta symbol, which means our change in y over our change in x. And essentially what this tells us is how much y is changing based on x. And the cool part about a line is that it's always changing at the same rate. So if you have some sort of xy plane and some sort of line, the cool thing is that if I have some sort of y1 value here, and I have some sort of y2 value here, and I have some sort of x1 value and some sort of x2 value, and the slope is essentially going to be this. And the really cool part is I can take any 2 points on this line. I can take this point, I can take this point, or I can take this point and this point, and whatever I pick, it's going to give the same value for m. Because that's the definition of a line. It changes the same way as you keep, if you take points on the line, it changes the same way. So that's the most important part about a line, which is m. And essentially, you can also think of it as how steep the line is as well. And what I showed you there was an example of a positive slope. But there are 2 other kind of slopes you can have. You can have a slope that's negative. And what that looks like is a line going down like that. So from left to right, it's actually decreasing. Or you can have a slope that is horizontal, or 0, which is when we have a horizontal line. It's not changing at all. As you keep moving x, my y-coordinate just stays the same. That's why the slope is 0. Or you can have a slope that is vertical, and we call this an undefined slope. So that's the m part. It's a very important part of the line. And the other part is this little b thing here. So b is what we call our y-intercepts. The y-intercept is essentially where the line intersects the y-axis. So it's the y-coordinate at which that happens. So if I have some sort of line that's like this, this point right here would be 0, b. And yeah, that's pretty much line basics. So you're going to need to be able to do a lot of things with lines. So I'm going to show you how to write a line I'm going to show you how to get the slope from just 2 points. And we already showed that. And 1 sec. So let me get a practice problem really quick. So let's take any point. Let's try and find the slope between the points 3, 2 and 7, 8. So to do this, what you do is you just take the points and you want to define what you're doing. So because this x value is later, I'm going to define this as x2. I'm going to define this as y2. So this is our point x2 comma y2, and this is our point x1 comma y1. And then we just put it into our formula, if you remember, our change in y over our change in x, which is just equal to y2 minus y1 over x2 minus x1. So y2 is 8, y1 is 2, x2 is 7, and x1 is 3. 8 minus 2 is 6, 7 minus 3 is 4, and simplify the fraction, we get a slope of 3 over 2. Now, how do you actually graph lines? Well, graphing lines is pretty simple. Sometimes teachers want like very specific like graphs, but really what you really need is just 2 points on a line, and that should work. So let's try an example. Let's say graph the line y is equal to negative 2x plus 10. So on the xy plane, actually let's change this. Let's just do negative 2x plus 1. It's easier to draw. Why don't we do it like this? So x and y. So most important thing here is I want to take a look at oh, that's weird. Anyway, slope and y-intercept. So as I said before, our y-intercept is just going to be 0, 1 because it's just 0, b. So we know a point on the line is obviously just going to be 0, 1. So this is just 1 point. So we have 1/2 of the line already finished. And now we're just going to use the slope to do the rest of it. So the nice thing about slope is that it basically tells us what to do. So because we have a slope of negative 2, nice, we can just go down 2 and over 1. So I'm just going to go down to negative 1, and I'm just going to go over 1 on the x-axis. Boom. And now we have 2 points in the line. Bam. Isn't that great? And you know, just make sure the line actually goes through the rest of those points. But you can really just do that. And then if you really want, you can go even further, get a couple more points. I can say, oh, let's just go down 2 because our slope is negative 2, and then we'll go over 1 more. So going down 2 from negative 1 gives me negative 3, right? And then this is another point line that I could graph. That's pretty much how you use slope to graph a line. And yeah, that's pretty much it with graphing. Now, something pretty important, or I guess pretty important. There are different forms that lines can be in. I taught you guys one, which is y equals mx plus b. But they're also, you can shift this around in many ways. You can say y minus mx is equal to b. You could say b equals, I already said that. You could say, I don't know, x is equal to y minus b over m. Like, you can do a bunch of algebraic manipulations, but there are different like forms that you can put a line in, and this is what we call slope-intercept form. But there's also what we like to call point-slope form. This is very helpful form of a line, and essentially what it is this. That's terrible. Let me rewrite that. This allows us to write an equation for a line, but when we just know 2 points. And I'll show you how to do that really quickly. So let's go back to our original. What was our original point that I used? Okay, never mind. Let's just use a different. So let's say I want to find the line that passes through the points 2, 5 and 6, 13. So we can actually use this to our advantage. So first I want to find the slope between those two. Because 6 is later, this is our x2, and this is our y2, and then this is our x1, and this is our our y1. What am I saying? We just do point slope. 13 minus 5 over 6 minus 2. 13 minus 5. I can't do mental math. Well, this is funny. I think. Yeah. And that gives us a slope of positive 2. Now, we have our m. Now, what are these guys? So, you can actually pick any point on the line to be x1 or y1. And it really just comes down to personal preference. I'm just going to choose this guy because we already defined it as x1 and y1. So, that's just going to be y minus 5 is equal to 2 times x minus 2. And then we can put it into slope-intercept form pretty easily. All we just got to do is distribute and then add 5 over. So what is that? 2x minus 4, so 2x plus 1. All right. And I'll show you it'll work even if I use this point. So I'll just do the same thing. If I do point slope, it's just y minus 13 is equal to 2x minus 6. If you distribute the 2 over and you add 13, then you will get the same thing, y equals 2x plus 1. And these guys are both the same. So using point slope form, we can actually write the equation between two lines. Or between two lines. The equation between 2 points of a line, which is nice. So yeah, that is the intro to lines.